Hello everybody. Today we're going to be looking at the last day of factoring in this unit. So there's just one more type of factoring we have to take a look at, and then we're going to do a small review at the end of this just to kind of go over the three different types of factoring we have looked at. So here are your suggested exercises right at the top there for day 4. And what we're looking at today is what we call special cases, and specifically in grade 10 we're looking at factoring with a difference of squares. In order to understand when we're looking at a difference of squares problem, we need to essentially understand what that means. So let's pick this word apart. So first thing first is, we should know this by now, but difference is a word that means the remainder left after subtraction from another value. In other words, it's the answer to a subtraction problem. So if you had 4 minus 2, the difference between those two values is 2. So whenever you're thinking difference, I want you to think about subtraction. Is there subtraction involved in your problem, yes or no? Squares is referring to the fact that there are perfect squares involved in the problem. Okay, well, a perfect square, as a reminder, is the product of a number multiplied by itself. So product being the answer to a multiplication problem of a number multiplied by itself. So if you look at here, I have listed most of the perfect squares that you'll be using. Doesn't mean you won't be using any perfect squares higher than that, but these are just the first ones you can think of. Well, 1 is a perfect square because 1 times 1 is equal to 1. 4 is a perfect square because 2 times 2 equals 4. 9, 16, 25, 36, 49, 64, 81 are all perfect squares as well, because you can take one value and multiply it by itself to get that product. If you continued, you would have 100 as 10 times 10, and so on and so forth. So when you're looking at a difference of squares problems, it's important for you to understand that you need to see some sort of subtraction operation, and you also need to see that the components of your problem are perfect squares. Okay? And that's kind of highlighted right here in these 2 points. So I say this, and it might sound very simple and easy to some, but sometimes there's tricks involved in the textbook or on assessments that you will see these problems, and we will be seeing to see if you pay attention enough to understand that it is a difference of squares. So I've divided it in 2 tables here: examples of difference of squares and examples of not. So all 3 of these things are difference of squares. How do I know that? Well, 1, I see that subtraction is involved, so the difference part comes into play. Next, I look at everything involved here. Well, x squared is essentially x times x. So this x squared is in fact a difference of squares. It is a perfect square. As we just talked about, 1 is a perfect square. 64 is a perfect square, and both these values down here, 81 and 25, are perfect squares. So everything involved in our problem is a perfect square, and they are using the operation of subtraction. So yes, these are difference of square problems. If you look to the right, these are not difference of squares. Here, x squared is a perfect square. Yes, you still have subtraction involved, but 7 is not a perfect square, therefore that is not a difference of squares problem. Okay, the second one, b, x squared is a perfect square, 49 is a perfect square, but the issue here is that we have addition and not subtraction in between these 2 terms, therefore this is not a difference of squares problem. And finally, yes, x squared is a perfect square, y squared is a perfect square, 25 is a perfect square. We have subtraction involved, but this 76 right here as a coefficient is not a perfect square, so we're not looking at a difference of squares problem. Okay. There's a shortcut to factoring these types of problems, and I'll show you that after we do the method that we have been doing this entire time. So, factor each of the following. Well, the first one is as simple as it's going to get, x squared minus 1. Now, if this was essentially a problem that you've been factoring in previous lessons, you would start by coming up with your table of values, or your t-chart, and you're going to put your c value here, what multiplies to c and adds to b. Well, what do you notice about this? We only have two terms. We're missing either our A term, our B term, or our C term. Now if you look at the general form of a standard form quadratic that I just placed up there, you will notice that we are missing our B term in each of these problems. There is no single x variable. This here is our A term, and here is our C. What that means, their B term is 0. So we're looking at two numbers that would multiply to -1 and add to 0. Well, the only factors of 1 are itself. So you're looking at this right here, -1 plus 1. Because -1 plus 1 is 0, -1 times 1 is -1. If you factor this, going through those steps that we have been, so, you would write those factors out, you would pair your first two terms and your last two terms, and you factor what's common amongst those. So x, what comes out is x minus 1. Here, well, you only can factor out 1, and you're left with x minus 1, and your answer is x plus 1, x minus 1. Now, that is the longer process. However, there's a shortcut when you work with difference of squares. So I will go over that for these two problems, and I'm sure most of you use the shortcut. Okay. What we're essentially looking for is to have two factors at the end of our problem, like so. Okay. What you want to do is just square root both terms. Well, in our problem we have x squared, so if you square root that, you're left with x. Okay, and then you have 1, and you're going to take the absolute value of these things, which means the positive version, and the square root of 1 is 1. Every time you come up with the difference of squares problem, you're going to have two factors, okay, meaning two sets of brackets. That first term that you took the square root is going to occupy the first part of your bracket. You're going to have one addition, one subtraction, okay, and then the second part that we took care of right here, the square root of 1, well, that's where you have that second portion, and our answer is the same. All we did was take the square root of two terms as opposed to going through the whole process of factoring. Okay, the same thing with the next one. If we're going to use the shortcut method, well, we only need to take the square root of x squared, which again is just x, and you'll see that commonly happen, and the square root of 64 is 8. Well, we know we have to have two factors. Our variable here is x, that starts our factors off. One is going to be addition, one is going to be subtraction every time, and then we also have our square root, which was 8. So this would be our answer for our second problem, x plus 8, x minus 8. Okay, if we move forward to C and D, you can see that we have some bigger coefficients, but it doesn't mean our problem gets any more challenging. Take them separately, okay, and let's try and take the square root. Well, what is the square root of 81x squared? Well, the square root of 81, that's 9. Square root of x squared, that's x. What is the square root of 25y squared? Well, square root of 25, that's 5. The square root of y squared is y. Therefore, set up your two factors. That first portion, so the 9x, is what we would put in the first spot of our brackets, 9x, 9x, one addition, one subtraction, and then you have 5y and 5y. Again, you can also expand your answer using distributive property and FOIL and see if you arrive back at the question just as a means to check that. And the last one for difference of squares would be 16x to the 4 minus 81y to the 4. What you notice here is that the exponents are 4 in both of these cases and not 2. And this is something to pay particular attention to, because sometimes we would call this a double difference of squares. So just something I've classified this as to identify that there are extra steps. So, same thing. Take the square root of those first two terms. So 16x to the 4 and the square root of 81y to the 4. Well, the square root of 16, that's 4. The square root of x to the power of 4 is x squared. And if you want to know why, well, x squared times x squared equals x to the power of 4 based on our exponent laws. Okay, well, what's the square root of 81? That's 9. And the square root of y to the power of 4 is y squared. So you would go ahead and you would write your problem out as you would be doing. So your two factors, 4x goes to the first portion, 1 is addition, 1 is subtraction. Then you have 9y squared and 9y squared. But pay attention here, and this is where it can get a little tricky. This right here can be factored a little bit further. We go back to what we started with. What is a difference of squares problem? Well, it involves perfect squares and it involves subtraction. If you notice, okay, this 4 is still a perfect square. Okay, you can take the square root to get a whole number. This 9 is still a perfect square, and there is still subtraction involved in this bracket. So what we're essentially going to do here is we're going to factor that second portion. The first portion is going to stay the same because why? Yes, we might have the perfect squares, but there's addition separating those terms. So we want to factor this. Well, let's go off to the side. What is the square root of 4x squared? That would be 2x. What is the square root of 9y squared? That would be 3y. So this actually further factors to become 2x plus 3y, 2x minus 3y. And now you have fully factored that problem. So just pay attention if your exponents are in fact higher than 2, that you might be looking at a double difference of squares problem. Okay? Now, that is difference of squares. That is the last type of factoring you will learn in grade 10. If you continue to go through this, we're looking at a review. So all three of the properties we looked at, or all three of the factoring methods, are on the following page. So let's do that now. So we started with, even before all of this, what we called common factoring. And that's the idea, and I'll just write a simple problem here. Let's say we have 4x squared plus 8x. Well, you look at what you have there, and is there something common to both terms? There was. It's 4 and also x, which leaves us with x plus 2 in the brackets. That's common factoring. Common factoring involves factoring something out that is common to all terms. This should always be step 1. Every time you're approached with a factoring problem, check to see if you can common factor. It will make your life that much easier. If you can't common factor anything, then it has to be one of these three ways. Now, if you look at our first problem, x squared plus 6x minus 27. The a value here is 1. And remember, way back we could go to a shortcut. So what we'll be looking at here is two values that multiply to negative 27, our c value, but they add to positive 6. Okay, should be getting good at identifying factors at this point. Those two values are 9 and 3, sorry, not in that combination. Should be negative 3 and positive 9, negative 3 and positive 9. Okay. And remember, if our a value is 1, we can use the shortcut. We don't need to go through the whole process of factoring because our answer or our factors at the end will be x minus 3, x plus 9. We can simply use the factors we came up with in the t-chart and place them into the equation like so. And you can do that every time for factoring an a value of 1. When we look at factoring with an a value greater than 1, so our a value here is 7, okay? That means that we can't do the method we just talked about. But I did say, let's check. Can we common factor something out of each of these terms? The answer is no, because you cannot factor 7 out of 6. You can't factor 7 out of 19. those things don't work. So what you need to do is come up with your t-chart. Whenever a value was greater than 1, on the right side we did a times c. Well, that's 7 times 6, which is negative 42. And our b value is negative 19. So we're looking at values that multiply to negative 42 and add to negative 19. Those two would be negative 21 times 2 and negative 21 plus 2. Okay, what would we do with those factors is write them out. 7x squared, and we're going to decompose or split our negative 19x into negative 21x plus 2x minus 6. And then we group our first two terms and our last two terms, as we've been doing, in common factor. Well, what's common between 7x squared and 21x? That's 7x, leaving us with x minus 3. What's common amongst 2x and negative 6? Well, that would be 2, positive 2, leaving us with x minus 3. And we would factor or finish it off what's left over and what is common. Now, if I extended that problem and I asked you to continue and say, well, what are the zeros? You would take both of those factors and set them equal to 0 and solve for x. So our first 0, or first value of x, is going to be equal to negative 2 over 7. Our second is equal to positive 3. You can use those zeros to solve for the axis of symmetry, and then eventually use that and plug it back into the equation if you're solving for the vertex. Okay, and the last type of factoring which we just looked at, which was difference of squares. So what we need to do here, and keep it simple, take your first term, which is 144x squared, square root it. Take your second term, which is 25, and square root it. Well, you're left here with 12x. Square root of 25 is 5. Set up your two factors. The first term is written in both brackets. One is addition, one is subtraction. Add 5, subtract 5, and you factor that difference of squares problem. Okay. Now, hopefully that's all right for you and you can do some practice with that. If you want to look at some additional types of factoring or trying to apply more than one concept at once, look at this problem here. Okay, my hints here will be common factor if you can, and then group in pairs at one point in your problem. Okay, take a look at that question, see if you can come up with the answer, which is this right here. If you need to clarify, if you want to see the steps of that solution, just shoot an email and we'll be happy to do that for you. Take some time, go through those examples and do the suggested exercises, and all the best with your factoring.